on behalf of the branch, thank you for attending this evening. If you are new to BCS Manchester branch, we organise a range of talks throughout the year, around about 8 per year, roughly once a month, although we do take a break over the summer period. We have another talk coming up later this month as well, which I'll give more details on later after this evening's talk. But welcome to the branch event. If we look at the grand challenges that we're all interested in, and particularly BCS in making IT good for society, we are all concerned around climate change, and we're all very much concerned around reducing our carbon footprints. And I think for many of us, we think of that as in things like travel. We think of that in terms of the number of server hours that we are using in our server rooms. But one area which we perhaps don't always think around is the actual software. And tonight, I'm very pleased that we've got Eric Z, who is the CEO of GoCodeGreen, joining us, who will be talking about how we can reduce the carbon footprint of our software itself, and looking at the code level. I think this is going to be a really interesting topic, and I think it will give us another sort of insight into how we can all look at reducing our carbon footprint. So without further ado, I will hand over to Eric.
Thank you so much. Hope everyone can hear me okay. So thanks, Darren. So yeah, my name's Eric Z. I'm the CEO of GoCodeGreen. Lovely to be here and to have you all here and choosing to be here. Just a bit of logistics. I'm expecting an Amazon delivery before 7 o'clock. It hasn't arrived yet, and so if there's a ding dong, apologies. I will ignore it. What am I going to do today? I want to talk about the context for why GoCodeGreen exists. I want to talk about the approach that we've taken, some of the results that we're gaining, and this is no sales pitch. This is more about me sharing with you why I've spent the last 2 years of my life committed to building GoCodeGreen and what we want to achieve. I was at a digital leaders event in Scotland 2 weeks ago, and just as I was walking in to do my talk, someone was walking out, and I said, "Oh, you should stay and listen to the next talk." He said, "What is it about?" And I said, "Decarbonising the digital world in which we all live." He said to me, "Oh, the green stuff, I'm not really that bothered." Anyway, that stuck with me. And thank you for bothering to spend some of your time this evening. So let me get on with it and talk to you about what we do and why it's important. Again, before I start, let me just ease myself in. I came to the UK in 1976. I came from Hong Kong and moved to London. Some of you look old enough who are showing yourselves, i.e. Tony. I can only see Tony actually. You look old enough to have been around in 1976, maybe not in London, but what you might remember, the summer of 1976, it was hot, yeah, and there was something that really freaked me out. I always remember it to this day. When I moved from Hong Kong to London, London was covered in flying ants, literally covered in flying ants. Kind of freaked me out. Anyway, I don't live in London anymore. I live in East Anglia in Suffolk. And really interesting, over the last couple of years, flying ants are reappearing, like swarming everywhere. Don't worry, bear with me. This is not about flying ants. Okay, I'll get to the point of this. What I did try to understand though was what's going on here, right? And this is a Met Office graph of the temperature since whenever it was, 1970 to 2022. And you can see they actually highlighted 1976 as one of those anomaly years of high temperatures. Isn't it fascinating that the last 3 or 4 of the last few years, that temperature keeps going up? And there's one thing that flying ants love: long periods of deep heat, and they go into their places and do flying ant stuff and multiply. They love hot temperature, right? That's the point. I looked at NASA's heat graph of the world. So this is again showing anomalies against standard temperature, June 1976. So you can see above the UK and Western Europe, a bit of a hot spot. You can see that actually though, on average, the anomalies in global temperature was actually pretty stable. Okay, that hot spot above Antarctica, a bit worrying, but you know, it's pretty stable. And you take this chart, June 2022, and you can see what's happening. And the point around these first few slides of my talk is that in my lifetime, it has changed. And so when I talk about what we do at GoCodeGreen, why we started it, there is something personal in there for me, which is, what do we do next? What do we do next? Some of you, I'm sure, would have seen or heard of, maybe even read the sixth assessment report, the synthesis report from the IPCC. It came out in March. It's fascinating reading. It's probably one of those things that everyone on the planet should read, but I'm not sure everyone does. But I did take an extract of 3 of the slides from their summary pack, which I thought were pretty good. 1, the scientists still have hope, amazingly. 2, that hope is based on action, you know, our ability to do things. You can read it in terms of the challenge, you know, cut emissions quickly, sharply, create a safer, sustainable world, scale practices in infrastructure and enhance resilience, cut global greenhouse gas emissions by half by 2030. Okay, probably all heard it before. The last slide there, though, I always find, you know, really interesting, which is, you know, that statement: our choices will reverberate for hundreds and even thousands of years. There aren't many times in your lifetime or your career where the choices you start to make may make a fundamental difference. I love technology. I've been doing this for 25 years. I'm a tech guy. You know, this talk is not about stopping doing digital stuff. It's not about constraining technology. What it is, and we live in a digital world, is trying to find a way to make all that software, all that technology that we love to design and build as efficient as possible. And that's the purpose of GoCodeGreen. So we are, how do I describe ourselves? We are a climate tech business. We are a tech business. We're a data business, actually. You know, we're 2 years old, so we're still young. We've spent the last 2 years building our calculations and methodology, and I'll talk a little bit about that in a second. So if you're expecting a deep code conversation, probably not what you're going to get today. I want to take an elevated view to give you a context for why this is important before you drop into code level. Yeah, our philosophy at GoCodeGreen is to measure, because measuring allows us to take action, and by taking action, we can reduce the carbon impact of digital products and services. And that's our mission. You know, we're here to identify and measure, identify actions to reduce the digital impact of the carbon impact of the digital world in which we all live. Despite being 2 years old, what we're doing is starting to resonate with people. So, you know, this again, it's not a sales pitch, but it gives you a sense of credibility, I hope. Multiple award winners. We are Google Brain Award winners. You know, the tech team that I've built doing this. We love technology. We're using technology for good. We've been recognized as one of the UK's most exciting new tech companies. And even more importantly, I think this is the biggest thing over the last, you know, at least over the last couple of months for us. We've just been nominated for the Earthshot Prize for 2023 in the Fix Our Climate category. If you know about the Earthshot Prize, it's the Prince William, David Attenborough thing that's really only 2.5 years old now. 5 Earthshots get selected every year. These are the things that the judging panel believe are the innovations that will help change and fix the climate and the carbon challenges that we face. you get nominated for the Earthshot Prize. So we were nominated by Climate UEA, the Climate Research Unit at the University of East Anglia. 50-year-old, world-renowned climate research unit. They decided that what we were doing is one of the things that they recognise as being an ability to help change what we do and how we do it. Okay. So, bit of context for what we do, why we do it. Let me start to give you a sense of why we started doing it. So, you may already know some of this, but the ICT sector, the information and communication technology sector, the sector we are all in, is now responsible for something between 4 to 6% of global greenhouse gas emissions. It's predicted to use over 20% of global energy by 2030. I know people talk about data centers a lot. In fact, every other conversation we're in at GoCodeGreen, someone's saying to us, yes, Eric, but I've moved to a major hyperscale cloud environment. I'm done. There's no more for me to do. They told me they're net zero, therefore I am. Yeah, that's not true. So there are other things to be done. But despite that, data centers, just data centers as part of the whole ICT sector, now account for the same carbon impact as the aviation industry. So this thing that and I think because you're here tonight and because it is the British Computer Society, I'm sure you kind of get a sense of the size and impact of digital capabilities and the reliance that we have as a society, financially, health, environment, all those aspects of our lives now are so dependent on digital capabilities. All good, we can make it more efficient. So let me give you another example. You know, I won't show the slide yet, but everyone talks about ChatGPT, GPT-4, right? Everyone's talking about ChatGPT now. Everyone loves ChatGPT. You, I'm sure, will know that the GPT stands for Generative Pre-trained Transformer. Transformer are large language models run on neural networks used for natural language processing. Very cool, right? Very, very cool. All kinds of opportunities to use that technology in really transformational ways. What you may not know, though, is that Transformer has a massive carbon footprint. So let me give you some examples. I like talking about these examples. On the left-hand side, the MIT did a piece of work. They looked at Transformer. And they calculated that one training event, a single training event, albeit on 200 million bits of data, but running on one GPU, that training event used the energy that created the equivalent of 203 tons of CO2. You'd have to plant 9,500 trees to go and sequester that carbon. It's one training event. So next time you're thinking about asking ChatGPT to write you a love poem in a style of the Red Hot Chili Peppers, just hover your finger above that button, that submit button, just for a second longer and think. Yeah, so hidden carbon impact. Bitcoin, a bit old news, but everyone knows Bitcoin is dirty, but how dirty? 22 million tons of CO2 per year producing and mining Bitcoin. You'd have to go and plant 1 billion trees to go and sequester that carbon. It's the same energy usage as the Netherlands. And then the last one, and I can't see anybody on this call, but sometimes when I turn up and talk about this stuff, I'm sitting in a room and there's a row of middle-aged men looking at me, and I say, oh, you guys look like High School Musical fans, right? And there's always one person who gives me a little smile. Darren showed himself, he's giving me a little smile there. High School Musical fan. If you were, then you would know that Olivia Rodrigo launched her song Driver's License and it went viral. New Statesman did a piece of work. They calculated the streams of that viral song used the energy that created the equivalent of 4,180 tons of CO2. Let's go and plant 200,000 trees and sequester the carbon of a viral song. But the point being, you know, that thing that we do every day, I don't even think about it, right? I do it too. And it is so massively convenient because, and the footprint of it may well be slightly less than actually printing a CD or a DVD, whatever, right? And actually then moving it around the country to get it to your house to then plug it into your machine to play it. But there is a cost, and a hidden cost of this. And what digital and technology does for us is it makes everything so much more accessible. Yeah, it makes it so much more accessible, so we can do it over and over and over and over again, literally back to back. So living in a digital world has a carbon footprint. Now, again, I have to keep reinforcing this, and maybe this is something we can talk about later when I finish, but I've been debating in my mind recently about how best to engage people around this topic, because it's a really interesting one, isn't it? Because people naturally, I think, in some ways, think that I'm trying to be regressive around technology. That, you know, by measuring and telling you something that you may not want to know, but telling you it, somehow I'm asking you to do something that sends you backwards in time. It's so far removed from the truth, actually, and we'll come back to that later on. But have a think, if you can, because I always like to have a conversation about these things, about the positive messaging around this, you know, the ability to change things in the right way, with the right purpose, and that it's not something that you have to do as an extra, right? It's almost an accelerator for the things you are already invested in, and then we'll come back to that in a second. Okay, so hopefully you get the point. Yeah, living in a digital world has a massive carbon impact. But then you start to bring it back to, well, why does an organization or company care about this kind of stuff? So I'm sure many of you work for technology companies, or if not a technology company, companies that are dependent on technology. You probably architect, design, build, sell, run software, if you're on this call, or somewhere associated with it. We all know that, you know, big organizations are doing digital transformations. They're becoming digital first. You've heard the words. What we believe at GoCodeGreen is that if you think about ICT and you think about the technology and the value chain of technology, we believe that software, if you think about a hierarchy, a pyramid, we believe software is at the very top of it. By being able to make your software more energy efficient, you can affect the whole of the value chain that supports that software, whether that's infrastructure, devices, network, you know, all the things underneath that are required to actually run and operate that software. That's our thinking. This picture on the right-hand side, it's one of the first pictures, or one of the first bits of analysis we did to actually understand whether we had something here that was going to be meaningful. Most of you will know or understand, you know, what the greenhouse gas protocols are in scope 1, 2, and 3. Scope 1 being those things in your direct control, often related to your facilities and the choices you make in those facilities, like the heating system you've chosen or the lighting system. You know, they're in your control. You can choose to choose something more efficient or not. Scope 2 being the indirect emissions related to the energy that you purchase to power those facilities. And then scope 3 is everything in your supply chain. And it's the hard stuff, you know, it's the really hard stuff, right? And most organizations struggle beyond business travel, waste, and water to really understand what's in their supply chain. So what we wanted to understand was what's the sizing of scope 3, and what's the sizing of the ICT components of scope 3? Because if it was 0.05%, I probably wouldn't be standing here talking to you after 2 years of doing this. But anyway, we looked at this, and we looked at the Carbon Trust work, where they say up to 90% of an organization's carbon emission impact can be scope 3, 90%. We looked at the Carbon Disclosure Project, and they do analysis and bits of work. One of those bits of work, I think from probably about 18 months ago, was a product level assessment across different industry sectors. They calculated up to 29% can be ICT related. So that kind of pause moment that says, okay, so organizations reporting against their carbon emission impact, doing a pretty good job in scope 1 and 2, don't really understand their scope 3 in the full extent. The majority of their impact can be scope 3 in their supply chain, of which a large proportion of that can be ICT and technology related. So for everyone sitting around this room who's bothered to be here today, there is an unbelievable opportunity in front of us to use technology to have an impact here. Yeah. And the challenge, the first challenge, before we even get to how do I cut the code, is how big a problem is there? How do I measure this thing? How do I actually understand what the hell is going on here? So let's talk a little bit about that. I don't know, Darren, the normal flow of these conversations, but I'm going to carry on talking, and then we leave questions at the end. Okay, cool, right, great. Right, so let's move on. Let me tell you about our approach. Our approach, we believe, is a world first, and which is great for a small climate tech business that's come out of the UK. And let me try and explain what it is that we think we've done here and spent 2 years doing. I'm going to say something that suddenly will be almost seem obvious, right? We treat digital products as if they are products. Okay, what does that mean? The Greenhouse Gas Protocol and the World Research Institute. Oh, I forgot to say something earlier on. You know, when I was talking about the IPCC stuff, and it's like, oh, the choices we make right now, you know, might reverberate. I remember, I like this one. When the IPCC report came out, it was a time of the Oscars, and Antonio Guterres, the UN Secretary General, said, you know what's needed right now, after he read that report? He said, everything, everywhere, all at once. I really like that. I thought it was really cool. Anyway, back to this. Greenhouse Gas Protocol. Okay, so they have a whole series of standards. You may have heard of them. You may not. So let me describe what we have taken. So there's something called the Greenhouse Gas Protocol's product standard. There is something called the Scope 3 standard, and really importantly for us, they produced a series of guidance, calculation guidance and methods specifically related to the ICT sector. If you haven't read it, you can Google it and you'll find it. It's 250 odd pages long. It is really interesting. It breaks down the ICT sector into component parts that you will all recognize: infrastructure, hardware, data centers, software, network. It then starts to apply methodology and standards in terms of recommendations of how you then approach understanding the carbon emissions related to the parts. It is not something that most people will read, okay, but we did. And the way I describe what we have done now is that we've spent the last 2 years codifying the product standard, Scope 3 standard, and the ICT sector guidance into our platform. And by doing so, providing a repeatable, consistent way of running measurements on software products. Let me explain that a little bit more. The product standard is really important, right? In fact, let me read this quote because it's so important. The Greenhouse Gas Protocol say the product standard can be used to understand the full life cycle emissions of a product and focus efforts on the greatest greenhouse gas reduction opportunities. It's the first step towards more sustainable product. The results can create competitive advantage by enabling better product design, increasing efficiencies, reducing costs, removing risks. Aren't those all unbelievable things to go for? The product standard effectively looks at a product, decomposes it into its life cycle stages, and goes about trying to calculate the carbon emission impact for each life cycle stage. By doing so, you can then target action at those life cycle stages. That's hard, right? So you can see the picture on the right-hand side. You take a product, you go through those life cycle stages, you're mapping scope 1, 2, and 3 impacts you're calculating. The chart below it gives you even a better sense of what's going on and what we're trying to do here. There are levels of specificity, okay, that the greenhouse gas protocol talks about. And you can see that product is at the very top, okay? When you're dealing with product, you're being as specific as you can about the carbon emissions at that level. When you're breaking that product into life cycle stages, go even further. Look at the things underneath it. Underneath product, you have activities and processes, then you have facilities, then you have business units, and then you have corporate reporting, okay? As I was saying before, everyone's reporting, well, big organizations are reporting on scope 1 and 2 pretty well, not doing a great job on scope 3, it's really hard, at corporate level. What we've done is we've gone as far as we can with the capabilities we have today and the data points available to us. And by the way, we always talk about the, when you're at the start of something, some of you may have been at the start of artificial intelligence or robotics or chat GPT. You're looking ahead and you're trying to create the momentum behind that thing to generate that momentum to get it going. We feel like that with GoCodeGreen. We're at the start of something that no one else is doing, and you're having to start to create the environment in which it resonates with people and they value it, so they can then use it. And we need lots of help, by the way, lots and lots of help. And that's why I keep talking about this is all really great. This is really, really cool stuff. But if leaders, if pioneers, if people who listen to these types of things don't think, actually, this guy's not crazy, but actually this is almost the gold standard of what we should be trying to do to make the biggest impact around the technology and digital capabilities that we love to build and operate. If we're not taking that action, then I don't know what we're going to do. And maybe, right? That's why I do these things, is to hope that someone in the room says, okay, let's have a look at that. Okay, so you now get a sense of what we're trying to do here, why we're doing it, a little bit about the method. Obviously, a lot of this is, the depths of this is all in our IP, but you get a sense, right? We're breaking the problem down, we're targeting the actions, and that provides the foundation in which we can then start to then do things. Let me talk to you a little bit now about what we're finding, because I think this is always interesting. So what are the results that we're seeing? I'll share this. 2 years down the line, we've worked across 5 industry areas. We've worked with over 25 organizations now. We've assessed over 40 software products, full product lifecycle assessments. That's the all-in cost with boundaries for a software product. That will include the people working on it, the developers and the testers. It will include the infrastructure components. It will include the network, the hosting choices. It will then go into engineering techniques that you apply to it. It will look at your DevOps maturity, your FinOps maturity. It will look at your ability to apply sustainable software engineering techniques. They're all weighted. We then run our calculations. We rate and baseline the product. We then identify actions then to move you to the next stage. And I'll talk a little bit more about that in a second. Okay, 40 plus software products, 25 organizations. For those 40 plus software products, 13,500 tons of CO2 calculated. So imagine the product never existed, now it does. Full life cycle assessments, 40 products. So you'd have to go and plant 613,000 trees to sequester that carbon. That's a build. Then you talk about the release and the use of that software, 14,400 tons of CO2, 655,000 trees going to sequester that carbon. I don't want to bore you with trees and numbers, but I want to give a sense of sizing and opportunity. Through the actions we identify for those 40 products, you can see the opportunity scaling that we're seeing as well. 54% on the core build, 34% on the release and use. just to bring that to life, let's look at the release and use number, 34%. If those companies, those 25 companies, are taking the actions we identified, and maybe they couldn't take all the actions, but let's just imagine they did. 34% reduction. That would have meant not emitting 4,900 tons of CO2, 40 software products. It would have meant not needing equivalent of 16 million kilowatt hours of energy. That means leaving 6,300 tons of coal in the ground. And really importantly, equivalent energy costs, not spending £3 million. So on every dimension, and if I can then convince you that the actions that can be taken are actions that will be fully aligned probably to your strategic intent anyway, as an organization, why wouldn't you do this? I don't know. I mean, I have no idea why people wouldn't do it. And this is the next stage of what I think we're up against now, which is how do you now convince people to take the action, because it's meaningful and has the scale of impact that we now need. And you know, I'm sorry, I'm just like kind of weaving around slightly, but this is a conversation. And you know, one of the things about the Earthshot Prize nomination, one of the things that I think is starting to resonate with people around why this is an Earthshot and the opportunity, because we do recognize we live in a digital world, is that the things we talk about, you can do tomorrow. This isn't about building carbon capture technology. This isn't about planting 50 million tons of kelp and waiting it grow, or 1 million trees and waiting 20 years for it to sequester some carbon. This is about the stuff that we're really good at. We understand technology, we understand digital capabilities, and we've got smart people in our sector who can fix problems. And the things that we identify are the things that we can do starting tomorrow. I really do have this thing that actually the technology sector could be the leaders in decarbonisation. And at the moment, and over the last 2 years, what I've experienced is so many technology leaders not really sitting in the back of a room, not really understanding how they can contribute towards their organisation's net zero commitments. I think that can change. So to get a sense of the impact, I'm just going to show you something now. As with all these kinds of new startup type businesses, you're always kind of conscious of what you show people. I'll show you something, and I hope it will give you a sense of what's going on. So, and again, a real life sense of the opportunity. So what we're doing at the highest level is taking a product, and as I said, calculating carbon emissions, carbon impact, and actions at life cycle stages. We use a system that's very much like a like a home energy report, or an electrical appliance assessment of the power usage of your TV, for example. Everyone recognizes it. It just resonates really quickly. So this is an assessment for a data application for a financial services firm. The data's real, obviously anonymized. Okay, so you can see carbon rating, because you see the top level, the current baseline position. No surprises that actually it's not that performant. One of the mindset shifts that needs to happen is that when you show someone this, they have to get over the thing that says, I've done a bad job. It's not about that. Yeah, they've probably done an outstanding job in terms of the capabilities of the application or the product they've built. They've probably done an outstanding job in terms of the accuracy and the feature sets. They've probably done a great job in terms of the efficiency of it. You know, what they have never considered, what they've never considered is the carbon impact. And so when you present this to them and give them the opportunity, without a doubt, those smart people will be able to then say, I can fix that too. I have absolutely no hesitation in believing that could be the case. Anyway, what we do is we rate it, and then we identify actions. I'll give you a summed up view of some of those actions in a second, rather than detailing, because that's not what this conversation is all about. And by the way, if you were expecting me to talk about code today, sorry, I wasn't going to go there. Right? Let's take the elevation first, because if you drop into code level now, I'll never see you again. You've got to have a context for making the changes, and that's really important. But anyway, so we're identifying action. You see those C ratings, and so you're going to say, well, why are they all Cs? Of course, any product could reach an A rating, but what we've done, what we spent particularly the last 6 months doing, is we've completely overhauled our ratings modeling. So before, it was very much based around like a home energy report, electrical appliance, very static. If you use this much, it means you're in this brand. What we've discovered is that every product that we're assessing is so varied, and because we're doing life cycle stage assessments as well, the parameters and variables become really complicated. So we needed to find a way of being able to assess and rate these products almost in isolation. So we do a rating based on that product itself and the choices that have been made. And the reason we chose to do that is because we're trying to drive action. I don't want to just say you could be an A rated, but you never take the action, because that means you have to change your location strategy for your engineers, for example. That may not be something that's palatable for you in the near term. So what we're doing now is almost like a next best action model, dynamic based on the product we're assessing, and then the next best action for you to take based on the parameters you've given to us in our assessment process. Okay. We think that's a much better way of doing it. So it gets you on the first step towards action. Okay, so we're calculating carbon intensity at a function point level within the software. So you're going to say, oh, but Eric, function points. Why are you using function points? What we have to do is to have some basis on which we can provide a consistent measurement and capability, ratings capability, so that we can benchmark things over time. At the moment, we need more data points, but we will get to a place where we will be benchmarking against similar type products. To be able to do so, you need to have grounding, a foundation grounding in something. We've chosen function points, ISO standard. We also recognize that it's really difficult for lots of companies and lots of software development teams nowadays who do continuous delivery, continuous integration, continuous deployment, don't think about function points in that way. So we've had to build models around that to be able to then do conversions. Okay, so I won't go into too much detail, but we use something called a backfiring gearing method to be able to then take developer effort from lines of code, gear it into programming language efficiency that then allows us to model the function points related to that engineering group and the time they're spending on building product. It's quite complicated, but anyway, we nailed it. And now, so that whole process now works seamlessly as part of the assessment process. It's pretty cool. That gives us that foundation basis on which we can then compare. And that's what drives our carbon intensity scoring. Okay, so you get a sense. I don't actually feel the need to show lots of detail. If anyone is ever interested, reach out. Then we can talk about it. What we do want to do though is show you something that I think might resonate. So again, keep it high level. So we've just come out of a piece of work for a global financial services firm. Just let you know, my Amazon delivery's just arrived. My Alexa, will whisper her name, is going to ring in a second, so just ignore. I'm going to carry on and try and ignore the door. Right, so we did a piece of work for a global financial services firm, and I just want to talk about the approach that we took, so it brings it to life. So a lot of these big organizations have hundreds, if not thousands, of applications. Whole mix, legacy, hybrid, some on cloud, some modernized, some cloud native, not many, and they're sitting on this stuff, right? And we turn up and say, okay, let's start doing some measurements, and they say, we've got 4,000 of these things, Eric. That's a lot. I don't know where to start. Therefore, I'm not going to start. So we try and break down the problem. So we basically say, look, take a sample. And in this case, they chose 6. A sample of applications that almost are reflective of that complexity in your estate. Different sizes of applications, two legacy, two modernized, couple on-prem, couple on private cloud, couple have been moved to public cloud. They have these complexities in their estate. And we said, look, take those examples and let's run assessments on those. Split location models. Some are a third-party package integrated. We calculate the work to integrate it. Some are fully in-house developed. We even had a mainframe one in one of these as well somewhere. But the point being, it's a reflection of your estate. And so look what happened here. We did a calculation across six platforms. We also did a bit of work and found that actually that business is in their annual reporting, they are saying that they emit 74,750 tons of CO2 as a business. So we look at those 6 applications, the proof of value applications, and we look at the reduction opportunity, the annualized reduction opportunity related to those 6 applications. And you can see the numbers there. There you go. It's going to happen, right? Teed you up. I am ignoring it. It's like it's on my. This living in a digital world, right? This guy is on my thing just underneath my. He's knocking anyway. And you can see the opportunity, right? So 0 points total. If you contextualize it for 6 applications, that's 0.74% reduction opportunity off your total emissions as a business. If you then do something different, which is say, well, if they were representative of your 2,000 applications, in this case 4,000 applications, let's take 100 of the biggest applications, or the ones that in the 80-20 rule are probably going to be the ones where you have most people, most cost, most infrastructure, and let's take 100, because a slice of 100 is immensely doable. And the likelihood is that the rest of those applications that sit in the background can be modeled around the results of the 100. And also probably many of those will be kind of end user compute type things. So these in isolation, independently, aren't the problem. So then you extrapolate. So you extrapolate the results from 6 to 100 and look at what happens. You then start talking indicatively of an opportunity to reduce the carbon impact of that business as a contribution from digital and technology of 12.37%. Now that starts, in my mind anyway, that starts to become a meaningful number. So we've taken a conversation from, is it important, to, okay, we can now start to measure it, to now scaling the scale of that impact that's available to an organization if they want to take this pathway. And it's starting to become meaningful. Let me talk about some of the actions. Everyone loves actions. What do you mean, Eric, by actions? So let me theme some of the actions for you. And as I said before, when I say everything is doable, nothing needs to be reinvented. These are the levers available to most organizations and most technology organizations and most technology departments now. You'll kind of get what I'm saying. Because we're doing full product lifecycle assessment for a product, we definitely want to understand usage patterns and profiling, right? Volumetrics, because that affects the choices you've taken, the scaling of the compute capabilities, probably the scaling of your hosting and network capacity, even down actually to the way that you've probably built the application. So it's an internal application that runs lots of data. It's a very different profile to a client front-end facing web app, for example. We're interested in your user profiles, usage patterns, volumetrics. Changing those can have a fundamental impact on the technology choices you make later on. We definitely want to understand where you're at in your sustainable software engineering techniques. We've built a self-assessment for developers. So based on everything we've learned, you can put your developers through our self-assessment. It takes half an hour, 25 minutes to half an hour. They ask us a series of questions, they answer them honestly, and then we score and rate. And so we get a rating per developer around their understanding of green coding principles and techniques. Really important, really important, because one of the big levers you'll have later on, once you've got rid of the hygiene type stuff up front, is you might need to start then doing the code level re-engineering. And you can start to see the things in there in terms of techniques. This is when it becomes really interesting for code at code level. Data caching and data exchanges, the energy consumption of features that you're designing and building, the energy related to logging, the choices you make around logging and polling. If you've got a web app, the type of images, high definition, your video, the compression techniques you're using. In terms of computational accuracy, we overspec everything generally. We don't, sometimes for some applications, you don't need to be so accurate. You can drive a decision, you can drive information in certain ways, but we overload, and it has a cost, an energy and a carbon cost to it. And then you can start to see around optimization of network traffic and data packets. So you get a point, right? So before you get there, do some of the other things, structural things in number 3. If you're moving to cloud, best start to think about the architecture of your design of the application. You really want to leverage the opportunities of that cloud environment using microservice architecture. You then start to think, well, if I'm having to re-engineer, what the energy efficiency levels of the programming languages I'm choosing, how many of the assets and components am I reusing, how much no-code capabilities have I deployed. All of those things contribute. Then you start to look at the underlying hosting infrastructure, the choices of your cloud. I do believe, by the way, I never want to have a fight with any of the big CSPs. They're too big. Hyperscales are really economic and fit for purpose for the right workloads. You've got to be careful about where you put it, which regions and zones you put your workload in. If you have a choice, you can drive a different conversation with your CSP. It makes a massive difference. Processor performance, absolutely. So there's a real difference between thermal device power at processor level, and based on utilization rates, that has a real impact. Cleaning up your compute, really, really important. How many times, I don't know you guys, how many times you've been in conversations where development and testing environments being overspec'd, you've got loads of these things hanging around, burning energy, but actually no one's really been incentivized to turn anything off. You can just clean that stuff up. This is actually the same with legacy applications. You've been sitting on a set of applications which you want to decommission for years. You find it really difficult because actually the money's been spent. You've written them off. There's always something else to do. They're sitting there burning energy. So if you start to understand the carbon impact of those legacy applications, maybe it will add something to your decommissioning prioritization. Then there's people. So the location strategies of your workforce, quite important. The level of travel they undertake is obvious, and commuting. The levels of working from home. Do they actually work from the offices? Everything in here has a footprint to it and a cost. And when you can break it down, align it and assign it to the product, then you can start to take action around it. Even the use of collaboration tools. And then number 6 is something we're starting to really get into now, which is that kind of third-party developer and support tooling piece. What's the cost, the carbon cost of using ServiceNow or GitHub, as part of your development for the product? It's quite hard that because, as you know, lots of this stuff is software as a service. It's shared over many, and you'd actually have to work with the vendor themselves to actually then start to open it up. But imagine we could, and imagine we can then measure it because we can, and then imagine we can have the right conversations to drive action because we can now as well. And that's effectively what we've been pushing really hard to do over the last 2 years. Just my last bit, and then leave it for a few questions, is we've done it to ourselves. as you'd expect us to. So as we were building, designing, building, and then reiterating our product, our own platform, we measured it, we took action, we reassessed. At the end of that reassessment, alongside our own carbon emissions as a business, we calculate the carbon emissions of our software, our platform, the service we provide to our clients. We've decided to compensate for any residual carbon with a partner where they plant lots of kelp, right? So we're actually verified climate neutral plus. Anyway, what does that mean? What it means is that if you use GoCodeGreen to run assessments in your business, we do not add to your scope 3. And the idea behind that was to try to create the conversation that says, imagine you could do that over and over and over again for as many digital products and services as possible, for all the key digital products and services that actually support, society, education, and health. Then we start to make an unbelievable difference. And you can remember, go back to the numbers and the sizing of the opportunity, and that's what we're trying to bring to life. So I'm going to, almost 1 hour in of talking, open it up for any questions. Darren, should I hand it back to you, or?
Yeah, thank you, Eric. So first of all, just thank you for that. That was a really insightful and thought-provoking presentation, and I'm sure there will be some questions. It's always a little hard to, give the appreciation that the such talk deserves online, but on behalf of everyone here, thank you.